Okay, yesterday's notes that you dealt with on your own was area of a parallelogram and area of a triangle. We're using those concepts to talk about today's figures, which are trapezoids, rhombi, and kites. First, let's take a look at a trapezoid. And if I have a couple of trapezoids and I orient them such, what are we looking at now? We're looking at a parallelogram. We know how to find the area of a parallelogram. It's base times height. In a trapezoid, however, we have two bases and their lengths are not the same. So we call this base 1 and we call this base 2. So the area of this parallelogram, what's the base of it? What's the base of this big parallelogram? Well, remember what I did. I took this trapezoid, I duplicated it, flipped it on its head. So if this is base 2, what's this guy over here? That's base 1. Remember, I took the figure, turned it around, and I ended up forming two parallelograms. So the base of that parallelogram now is what? The base of that whole parallelogram. Right, base 1 plus base 2. And I know some of you are familiar with the formula, but I want you to understand why formulas are what they are. Okay, so the area of this parallelogram is base 1 plus base 2 times the height of the trapezoid, which I would hope you'd notice is also the height of our parallelogram. So that's the area of this parallelogram, but remember the area of the trapezoid is what fraction of this parallelogram? Half of it. So there's that 1/2 height times base 1 plus base 2 that I'm sure you've seen before, and it is on the reference sheet. But again, in this class, I try to push you to see why things are and not just, here's a formula, take my word for it. Right? So in problem 1, we're just finding the area of the trapezoid using this formula. Do I have all of the pieces of information that I need to just plug into this formula and run with it? Yes or no? No, I don't. What am I missing? I'm missing the height. Any thoughts on how we're going to find that height? Because certainly they're not going to give you a problem that's impossible. Yes. Right, we can either use trigonometry, or what I'd really like you to realize is that there's something special about that angle that they're giving you. 45, 45, 90, gentlemen and ladies. So what is this segment down here? What is the length of that blue segment I've just highlighted for you? Say that again. You can find the length of that segment. Look at the diagram, Lily. It's 6. Before I go any further, are we not seeing the 6? Okay, so if this is a 45, 45, 90, and this leg is 6, the height of that 45, 45, 90, what is it in the 45, 45, 90? In other words, the height of the trapezoid is what? A leg or a hypotenuse of the 45, 45, 90? It's a leg. Well, gosh, that's really convenient because in a 45, 45, 90, what do I know is true about the legs? They're the same thing. Remember, a 45, 45, 90 is an isosceles right triangle. Okay, so my height, that was easy. My height is also 6. Okay, so now it's just a matter of plug and chug. 1/2 times 6 times base 1 plus base 2 will give us our area. So that's 66. Square millimeters. Did someone run the numbers? Thank you. We have from this screen what we need. Yes, ma'am. No. Remember, 2 plus 3 is the same thing as 3 plus 2. Okay, good on the screen. The your turn in your notes is a Centillo question, so when you have answered it, please enter the answer in your Centillo. Yeah, it's running in anonymous mode, so it should be letting you enter the classroom. What? Oh, okay. All right, well, I'm figuring out the technology that isn't cooperating with me. You've got the math in front of you that you can be working out. Is it letting you log back in? Or remember, 1/3 of something times whatever, same thing as taking that value and dividing it by percent. Yes. And now it's saying, welcome to the okay. Huh. Okay. All right, well, okay, it says the question is started. Maybe the technology isn't going to cooperate with us today. At any rate, I'm sure you've done the math by now. You've got 1/2 times, I'm making the ugliest 1/2 times my height of 7 times the sum of my bases, 12 plus 15. And we've got I have 94.5. Good? And square centimeters. Okay, so it's looking like the Centillos aren't going to cooperate with us. Go ahead and turn them off and just set them aside on your desk. Don't worry about bringing them up until the end of the lesson. We're good on this screen? Okay. So how about a kite? In a kite, notice the way that I've drawn this kite out for us. I've drawn it so that what I'm looking at is 2 separate triangles. And that's kind of what I want you to realize is that a lot of these formulas come into being by taking a figure and breaking it up into smaller pieces for which we already have a formula for, and then kind of putting the pieces together. Hi. Hi. Special delivery for this one. Oh my God, you're hiding in the back corner. I couldn't see you. All right, so resuming, we've taken this kite and broken it up into 2 triangles. So I'm going to find the area of this red triangle, and then I'm going to find the area of this blue triangle, and as you can guess, we're going to take these areas and add them together. So notice that I've labeled the base of this triangle as D1. Do we see that the base of the red triangle is the same as the base of the blue triangle? Okay. So area of red triangle is 1/2 times the base of that red triangle is diagonal 1. And the height of that triangle I've labeled as h1. Nothing too complicated. I'm just taking the formula for the area of a triangle, taking these like variables that I've used to identify base and height of the triangles, and you'll notice something when we put it all together. Area of the blue triangle, kind of the same idea. Its area is 1/2 times, remember the same base, that's diagonal 1, times h2 is the height of the blue triangle. And as I said previously, we're going to take these two triangles and add them together and see if we can't come up with a nice, concise little formula that works for all kites. So when I take these two areas and add them together, I have that the area of my kite, this isn't my formal formula yet, the area of the kite is this 1/2 d1 h1 plus 1/2 d1 h2. Let's bring some algebra into this mix. Looking at this algebraic expression, if I wanted to factor this expression, if I wanted to simplify this expression, I would look at those two terms and I would notice that they have a couple of things in common. What do they have in common? The d1 and the 1/2. So I can factor that 1/2 d1 out as my greatest common factor, and you've seen this before. You did this last year in algebra. So I'm rewriting this as 1/2 d1 times h1 plus h2, which is what I have left out of those terms when I pull the 1/2 d1 out. Look at the diagram again. I kind of gave it away that d1 stands for diagonal 1. If I take h1 and h2 and add them together, what is that? Diagonal 2. So our formula for the area of a kite is 1/2 diagonal 1 times diagonal 2. So if you know the diagonals of a kite, you multiply them together and take half, there's its area. What do kites and rhombi have in common? What do kites and rhombi have in common? What property do they both have? Diagonals that are what? They're perpendicular. So that same formula that we just found for a kite can be used in a rhombus. 1/2 diagonal 1, diagonal 2. This formula is not on the reference sheet. Okay? So parallelogram, triangle, trapezoid, that's all there. Half diagonal 1, diagonal 2 is not on your reference sheet, but that's where the value of showing you why the formula is what it is comes into play. Perhaps by virtue of seeing that formula, even if you forget the formula. At the very least, perhaps you'll remember how we came up with it, and you'd be able to do that on your own. Okay? We have from this screen what we need. So let's find the area of a kite. What are the lengths of my diagonals here? 10 and 8. So our final answer is 40 square inches. There's a your turn there in your notes. Please take a moment to work through that. the area? 54 square feet. Just to clarify, it's 1/2 times 9 times 12. Good? Great? Golden? Oh my gosh, Mrs. Clouse, this chapter is going to be awesome. No, I promised you all proofs were done after chapter 7. Okay, problem 3, finding the area of the rhombus. Once again, do we have the information that we need in order to find this area? That's the first question you always want to ask yourself. Area of a rhombus is 1/2 diagonal 1, diagonal 2. Do I know the length of the diagonals here? Yes, they didn't draw them in the way they did in the previous problem, but they're giving you all the information you need. And I have 65.1. Square meters. And there's your turn. And I'll be activating the daily quiz on Socrative. And then I'll put the book on the screen, because look at all that time we have. Whew. Okay, daily quiz has been activated, but I quickly want to go over problem 3. This time, notice it's not giving you the length of both diagonals. It's asking you, or it's giving you side lengths and one diagonal. So drawing the diagram might be helpful here. I know that the side lengths are 10, and it's telling me that the longer diameter is, or longer diagonal, is 16. I know I need to find the length of the other diagonal in order to find the area of this. Any thoughts on how we're going to do that? Think about that property of a rhombus that we mentioned earlier. What do you know about the diagonals of a rhombus? They're perpendicular. So if I draw this diagonal in, what kind of triangles do I have? Right, triangles. And I know that this is 10, and this segment here that I'm highlighting in blue, what is its length? No. This is 10. This blue segment, I heard it, very good, it's 8. How would I find this segment here? Pythagorean theorem, yes. So x squared plus 8 squared equals 10 squared. And it works out nice and pretty. X ends up being 6. So what's the length of the diagonal? 12, which means I now have everything I need in order to find its area. I have 1/2 times 16 times 12, and that's 96 square centimeters. Okay, again, there's daily quiz activated on Socrative. Make sure that you're taking. What did I calculate something wrong? And I'll be putting the book on the screen. Please make sure you've turned your Centio off and return those to the case, please.